Now that we understand how the starter works, let's do some diagnosis. When we turn the key to the start position, we're anticipating that the starter motor will turn, the engine will turn, and then the engine will start. When it works, life is good. When it doesn't work, we usually get one of several different scenarios. Either we're turning the key to the start position and we hear nothing, or we turn to the start position and we hear a click, but the engine does not crank, or we turn the key to the start position and the engine is cranking, but it's cranking very slowly and not strong enough for the engine to start. And when I say turn the key to the start position, on many cars today, you would just be pushing the start button, which is the same thing. When you push the start button, you are essentially just turning the key to the start position. The button just operates a little differently. If we hear nothing when we turn the key to start, we need to make sure we have a good battery. We need to see that there's 12 volts or 12.6 for most cars across the battery. And this is just a quick test because there are special testers that actually test the capacity of the battery and the condition of the battery. But for the do-it-yourselfers, this quick test will at least give you an idea of if there's a bad cell, which would read maybe 10 volts and would lead you to believe that the battery may need to be replaced before you go blaming the starter. So if there is 12 volts or 12.6 across the battery, and we're going to just use 12 because it's just easier to say repeatedly over and over, even though we mean 12.6 or the normal battery voltage. So once I have that reading across the battery, then I would make a measurement at the B terminal of the starter. I would connect the red lead here and the black lead to a good ground. And you should have 12 volts at that B terminal. And getting 12 volts at that B terminal will tell us if there's an open in the circuit from the battery to the B terminal, but it won't tell us if there's a high resistance problem yet. Because for high resistance to be apparent, we have to actually have the circuit operating. So if we were cranking the engine and we were measuring 12 volts here, then that would be a good reading, meaning that there's no high resistance problem on the way to that terminal. But until we have an active circuit, the high resistance is not visible, or at least not visible to the voltmeter test. So once you've tested for 12 volts at the B terminal, we would then come over to the S terminal. Where the B terminal needs the voltage there at all times, the S terminal only gets the voltage at that terminal when we are turning the key to the start position. So if you would hook up your meter the same way we did to the B terminal, the red lead would go to the S terminal and then the black lead of the meter to a good ground. And you should read reasonably close to 0 volts. And then when you turn the key to the start position, you should read 12 volts. And if you still read 0, it means that there's something wrong with the path on the way to the S terminal. And it could be the fuse, it could be this wiring, it could be in the switch where you're turning the key, but it's actually not completing the path, or it could even be this wire here. If you measured, say, 5 volts or 6 volts or even 7 volts, that would signify, while you're turning the key to the start position, that there's a high resistance problem before you get to the S terminal. So if only 7 volts is getting to this point, that means 5 volts had to be used up somewhere on the way back here. And again, it could be the same thing as we discussed for the open. It could be in this wiring, it could be inside this switch, or in this wiring. It just means that there's some voltage being used up on the way to the S terminal. And the way we would find it is just by moving our meter lead back toward the power source. And if I had 7 volts here, and then came back to this location and was able to hook my meter up to a terminal on the switch, if I got 12 volts at this point while I was in the start position and 7 volts at this point, that would mean that this wire in between here has high resistance and is using up the other 5 volts. If I had 7 volts here, just like I had the 7 here, and then I had 12 volts when I measured at this location, then that would mean that the ignition switch is using up the 5 volts, and that would need to be replaced. And the same thing, if I had 7 volts here and then had 12 volts on the output of the fuse, then it would mean that the high resistance problem is in this wire. So in order to get the starter to operate, we need to get 12 volts to the S terminal or solenoid terminal, and we need to have the 12 volts at the B terminal. And usually if you hear nothing, you either have a very weak battery, which is not able to provide enough voltage to activate the solenoid, or you have something wrong with the power circuits going to either the B terminal or the S terminal. Now, what if we have the second scenario where we hear a click, but the motor does not spin? If you hear a click, that means that the solenoid circuit worked. That's telling you that this whole path here operated, and it pretty much saves you from having to make a test down at this S terminal. If you hear the click, but you have no motor cranking, then maybe there's something wrong with the cable going down to the B terminal, or the switch inside the solenoid, or in the motor itself. So when you have the click and no crank, you're pretty much testing on the motor side of the circuit, which is this path here. And while you're cranking, you would make a couple of tests. You would hook your meter up for a voltage at measurement, again, like we did before, red lead to the B terminal and the black lead to a good ground. And while you're cranking, you would expect 12 volts here. And if you did get the 12 volts here while you're cranking, then you would move your meter lead over here to the M terminal and see if you get the 12 volts at this location while you're cranking. And if you do, it would mean that this switch inside the solenoid did close and allow the 12 volts to get down to the M terminal. And if the motor is still not spinning and you're providing 12 volts down at the M terminal while you're cranking, then more than likely you have an issue inside the starter motor. Now, what if we had 12 volts when we measured at the B terminal, but did not have 12 volts at the M terminal, and we had 0 volts at the M terminal? That would mean that this switch part did not close and complete the path. Or maybe we had 5 volts at the M terminal, meaning there's corrosion on the contacts of this switch that's inside the solenoid and using up some of the voltage so that the motor terminal does not get the full 12 or enough to get the motor to start spinning. So in either of these cases, once you've determined that the problem is inside the starter or the solenoid, more often than not, you're going to be replacing the starter. Years ago, many places would repair the starter by changing just the solenoid or changing just the starter drive, or cleaning the contacts on the switch, or replacing the brushes inside the motor. But nowadays, more often than not, you'll be replacing a starter. Even if you bring it to a repair shop or a dealership, they'll still be just replacing the starter instead of taking it apart and fixing the one part of it that's broken. And it's just become commonplace to do that. And there could be lots of reasons for it. Part of it could be it's not worth stocking all of the parts for it in all of the different repair centers. It could be that there's not enough qualified technicians to do the overhaul of those different devices, so it's easier to just do the starter. Or they can mass produce the starter and get the price down to a reasonable cost so that if you needed a couple components inside, you would get up near the price of the starter anyway. Just realize that over the years, if you're going to be doing something yourself where you're going to attempt any kind of starter repair, more often than not, you'll be replacing it unless you can find an outlet that can supply you the internal parts for the starter. Our third scenario is that the motor is cranking, but it's cranking very slowly. And if it's cranking slowly, we would start at the battery again and make sure that the battery voltage is good. And another thing that people will do as a do-it-yourselfer, if you don't have the test equipment for the battery or to do current draw tests on the starter, you could turn your headlights on and turn the key and see, did I have bright headlights before I turned the key to the start position? If I didn't, then that's signifying that the battery is weak. And if I do have bright headlights and then when I go to crank it, the motor cranks slow, but the headlights go almost off, that means I'm getting a high current draw inside the starter, and it's more than likely going to be an internal starter problem. In some cases, you may have heard of people tapping on the starter itself with a hammer and getting the car to start. What you're doing there is you're just trying to free up some type of a poor connection or something that is jammed inside either the solenoid or the starter motor. So if you have a condition where you're getting no click, but there's 12 volts down here at the starter, you could tap on the solenoid and see if it makes a difference. And sometimes you might be able to free up the plunger if it's sticking, or maybe the fork is binding, or whatever's going on inside. Something that would just jar it a little bit, and you have to tap it lightly while you're turning the key to the start position. And if you do that when there's no click, as long as there's 12 volts here at the starter, you might get the solenoid to activate. Now, if you have the click and the motor's not spinning, you wouldn't tap on the solenoid, you would tap on the starter housing. And in some cases, as long as you're getting 12 volts down here at the motor, if you tap on that housing, you could possibly get the motor to operate, and it would just save you from needing a tow that time. It doesn't fix the starter, it just lets you know that the starter is bad, and it just gets you out of a situation where you're not stuck, at least this time. In the next video, we're going to look at a more complex version of a starter circuit, which has the same basic schematic as its core, but it adds several different other switches and features that make the picture more complex, but the diagnostic principles involved to testing it will be the same. So I'll see you in the next video.